Hi, everyone. I just wanted to start with a video of myself to say I really miss you. I met with some of you in office hours the other day, and it just really it reminded me how much I love my job because of you guys. And now that we're all at home, I don't get to see you guys, and I miss you, and you make my job so much fun. So just want to say I'm here for you, even though we don't get to see each other every day. So I welcome all emails and questions. And even if you just want to say hi, send me an email, say hi, because I love to hear from you. Even to know even if you're doing something cool during this time, I'd love to hear it. Just to hear from you. So anyways, we're going to start our next lesson. But I just wanted to say hi and that I miss you all. And I hope you're safe and happy and healthy. And you're doing a good job on your homework and keeping up. I know you have to pace yourself, which can be challenging, but you know, this is good. There's lessons within it to learn how to gauge your time and take control of your learning. So let's go ahead and get started. I'm going to share the screen and pull up our lesson, which is going to be, well, it should be ready. Is it minimized? There it is. Okay, let me cancel and try again. Okay, share screen, and then let's go ahead. There it is. All right, my lovely geometry. We're going to be using inscribed angles and polygons. So this is section 10.4. Okay, let me get my draw tool. Actually, I'll need my mouse first. All right. So here's some vocab for you guys. An inscribed circle. Typo. Inscribed angle. So let me see how I can wipe this out. Let me get a shape here. It should not say circle. This should say angle here. Inscribed angle. It's an angle whose vertex is on a chord and whose side contains chords of the circle. Okay. Ugh. So all it is, guys, it's an angle where the vertex sits on the circle. That's all it is. Now what you're going to see is this angle, when you extend the side lengths, it's going to intercept an arc. We call that the intercepted arc. Okay, so these are two vocab words we're going to be talking about. There's going to be a very distinct relationship between this angle here and the intercepted arc. In fact, the relationship is whatever the inscribed angle is, the arc is going to be twice as big. So that is the gist of today's lesson. We're done. No, I'm just kidding. These can get hard, so I do suggest you stick through and practice these because they definitely can get hard. We're going to skip these cases. I don't think they're important for our needs. All right, so here we've got, here they're giving you the theorem of what I just spoke about. They're saying the inscribed angle is going to be half the intercepted arc. Instead of using the word half, because I know many people don't like fractions, I like to think of the other way. If the inscribed angle is x, your intercepted arc is going to be 2x. So then you're thinking of doubling, and then of course you can half if you're going backwards. So let's actually put it into practice. Let's look at this example here. Find the indicated measure in circle P. So we want the measure of angle T. Okay, so here's angle T. So we're looking for this angle here, okay? So what I suggest is, I'm gonna get my line tool, extend the lines of the angle so that you can see the intercepted arc very clearly. If I were doing this on paper, I would highlight it. So my intercepted arc is 48. So if this is 48, half of 48 would be 24. So angle T is 24 degrees. Okay, now they want the measurement of arc QR. Remember this symbol up top, it's curvy, means arc. All right, so the measurement of arc QR. Ooh, that's right here. Let me kind of undo, or let me just erase. I erased everything. How do I undo my erase? There we go. I just want to erase my picture because we're focusing now on arc QR. and arc QR isn't being intercepted by an inscribed angle. So this is going to take a little bit of work, okay? What I see here is this is 50 degrees. What I also see is that this is a diameter. TR is a diameter because it's going through the center, okay? Always look for diameters and radii. They're always going to be your shortcut, or not shortcut, your ticket out. So if this is a diameter, that means this is a semicircle, as is this. This is a semicircle, which means it's 180 degrees. So that means this whole arc, arc TQR is 180. Okay. So what I see here, if this angle here is 50, this inscribed angle, that means this has to be 100, because remember this is twice as big. So arc TQ is 100, which means the remaining has to be 80 because it is a semicircle. So arc QR is 80 degrees. Since we're here, why don't I have you guys find arc TS? So take a moment and pause it and find what the measurement of arc TS is. That's here, TS. All right, let's go ahead and find it. Hopefully you found it already and you pushed play. So I can see that I've got a semicircle because we're capitalizing on the fact that this is a diameter. So if this is 48 degrees here, guys, the remaining has to be 180 minus 48. Yes, I'm going to use my calculator because I'm the queen of small mistakes and I don't want to make one. I'm getting 132. So TS, arc TS is 132. All right, we're going to keep going. Find the measurement of arc RS and the angle of STR. What do you notice about angle STR and angle RUS? All right, what a mouthful. Let's start from one question at a time. Find the measurement of arc RS. So they want this arc here. All right. When there's more inscribed angles, like we've got a lot of inscribed angles here, highlighting things is nice. And then like I did on the previous example, so this is your intercepted arc. So see where angle it comes from by highlighting the rays of the angle. So it's being built off this 31 degrees. So if this is 31 degrees, the arc has to be twice as big, which would make it 62. Okay, now what I want you to also notice, I'm going to change colors, is that you've got another angle that's intercepting 62 degrees. So check it out. So angle STR is also intercepting 62 degrees. So that means this inscribed angle here would also be 31. Okay, so they want the measurement of arc RS, which we found, 62. And find the measurement of angle STR. Oh, we found that. That's 31. What do we notice about STR, boom, and RUS? Well, they're congruent. And why? Because they're intercepting the same arc. So I'm going to write that. They are congruent because they intercept. So let's go scroll down to this theorem below. This is simply saying if two inscribed angles intercept the same arc, then they are congruent. Obviously, that shouldn't have to be, if you ask me, it shouldn't have to be a theorem because that makes sense. But yeah, geometry people like to give us theorems. We're going to skip this example and we're going to go ahead and move to the next. So this is a good point to pause, and they're asking for finding the measure of the red arc or angle. So find the measure of this red angle here. Find the measure of this red arc. Find the measure of this red angle here. Okay, push play once you're ready. All right, lovelies, welcome back. So let's first focus on, okay, let's do number one. They're looking for this angle here, okay? Now, so if this is 90, then this would have to be half of it, which would make it 45. That's not so bad. I do want to draw your attention because it should be noted, guys, this is a diameter. always, always note when you've got a diameter. I didn't have to use it in this example, but it's just good to always find your diameter. They didn't give us diameters in 2 or 3, but you know, sometimes people get stuck in a jam and diameter gets you out. So for example, the remaining arcs, arc GF is 90 because this entire semicircle is 180. And then the other side, this entire semicircle is 180. Now they obviously didn't ask for all that information, but why not? Let's go for it. Okay, so number 2. So if my inscribed angle is 38, then the arc is going to be twice as big. So that's 38 times 2, which would be 76. Okay. Now on 3, you've got a couple intercepted or inscribed angles. So let's go backwards. Okay, so 72 is an inscribed angle shining on this arc here, which would be double, which would be 144. Okay, so then knowing that that's 144, I see this angle here. Let me change colors. I see this red angle here is also intercepting the same arc. So that means this angle X, the angle they're looking for, is also 72 degrees. This is from the above example where if they're intercepting the same arc, then they've got to be congruent. I didn't necessarily have to say this was 144 to know this was 72. In fact, I could have, let me just erase, I could have just been like, oh, wow, look, they're intercepting the same arc. If this is 72, this must be 72. So that's the idea of the theorem. It can make it quicker for you if you see it, but it's not one you have to memorize because there's always a work around it. Okay, so here's some more vocab for you. So an inscribed polygon, both of these pictures are examples of that. That's a polygon inside a circle, and what's important about that is all vertices are touching the circle. Okay, and then this is another polygon inside the circle, all vertices are touching it. Then, so I like to think of it inscribe inside, you know, it has the same idea. So it's an inside, the polygon is inside. Polygon is inside. Now, let me just show you what you can't qualify. You couldn't call this an inscribed polygon. This is not an inscribed polygon because the vertices are not touching the side of the circle. This is simply just a quadrilateral inside a circle. Okay. Now, a circumscribed circle, this is still the same example, that's a circle around the polygon. Circle around polygon. And the polygon is touching all sides of the circle. No, all sides of the polygon are touching the circle. There's infinite points on a circle. All right. So there's going to be some ideas going on with inscribed polygons. Okay, mainly we're going to look at triangles and quadrilaterals. So let's talk about a triangle first. Okay, what this is saying is if you've got a triangle inscribed in a circle, then, and one of the side lengths is a diameter, then you know that the angle opposite that has to be 90 degrees. So I also don't think this theorem is very profound, and here's why. So if this is a diameter, then you know this is a semicircle, this is 180. Okay, so if this is 180, then angle ABC, this angle here, is intercepting a semicircle. It's literally intercepting half the circle. Half of 180 is 90. So I don't think this theorem's that profound. I kind of call it a shortcut if you want to recognize it as that, because you could just say, oh, it's intercepting 180, half of 180 is 90. All right, moving right along. Now, when we have an inscribed quadrilateral, this is very important, and I want you to start this because a lot of people forget this, and I've seen it come up on the SATs and ACTs and state testing, and you know, it's just quickly forgotten. So what this is saying, guys, is that opposite angles are supplementary. So anytime you've got an inscribed quadrilateral, opposite angles are supplementary. Oh, it's up here. I don't need to rewrite it. Opposite angles are supplementary. All right, so you can always count on that. Okay, so we're moving right along. So these would be examples where we're going to use opposite angles being supplementary. Find the value of each variable. So I'll go ahead and do A, and then you should pause it and do B on your own, okay? So what I see is I always like to make a connection between my opposite angles. So that means 80 plus X have to equal 180. 80 plus X equals 180. So then that means X is 100, okay? And then let's find Y. So to find Y, that means 75 plus Y has to equal 180. So that would mean Y is 105. Okay? There's no real connection between consecutive angles. The connection is opposite angles. So why don't you pause this and go ahead and start B and then push play when you're ready. Okay, welcome back. It's been so long. I know, you guys miss my corny jokes. Just say it. All right, so let's go ahead and find, this one's just a little more complex equations. I like to circle my opposite angles. It just, helps me make connections. So then this would be 2A plus 2A equals 180. So that's 4A equals 180. So then A is, looks like 45. Okay. Now, to find B, you would write equation using these two opposite angles. So that would be 4B plus 2B equals 180. So 6B is 180. Oh, that's not a 180. So B is 30. Okay, they just wanted the value of the variable, so there's no need to plug B back in and find the actual values because they simply just wanted A and B. All right, guys, I know you're doing great. Let's keep moving. We're nearing the end. Okay, 2 more examples. Why don't you pause and try on your own? This is actually our last slide. Whoop, whoop. All right, guys, welcome back. Let's go ahead and finish this. So I would write my equation because I see opposite angles are supplementary. 68 plus Y equals 180. So then Y would equal whatever 180 minus 68 is. 112. Guys, I'm the queen of mistakes. So if you ever find a mistake, please email me and let me know, and you'll get an extra credit point, and I'll let everyone else know there's a mistake too. I'm sorry if I make a mistake. I don't try to. You guys know me that I don't know, my brain's all over the place, and especially being home, I call it quarantine brain. It's just kind of been fuzzy. So sorry if I make a mistake. You guys are lovely for finding them. All right, so I'm now finding my X. So X plus 82 is 180. So then that would be 180 minus 82 equals X is 98. Now, the silver lining with me making mistakes, I wish I could say I do it on purpose, but I don't. If you find a mistake, that's good. That's high-level learning. That means you really know what's going on. And, it's good to email a teacher when you find a mistake. That's you're on it. So I'm never offended. I just feel bad that I make mistakes, but at least I'm human. We're all human, so we make them. As long as you admit it and fix it, I think it's all good. Okay, so now our last example, opposite angles are congruent. So that would mean, ooh, opposite angles are not congruent. I'm sorry. There's my mistake. I'm all harebrained now. I'm excited. Opposite angles are supplementary. 10x plus 8x is 180. So 18x is 180. So x is 10. Okay, let's go ahead and just set up our other equation. C plus 2c minus 6 is 180. So that's 3c minus 6 is 180. I see a lot of people make a mistake here and accidentally will call this 174. But remember, you're adding the 6, so it'd be 3c equals 186. Something I see a lot, we make mistakes, we're human. So then C would be 62. All right, guys, that concludes our lesson for today. You did fabulous. I miss you all, and I wish you well. Thank you so much.